Look up at the night sky, what do you see? For most of us it's a moment of wonder, a reminder of how small we are in the grand scheme of things and how much there is left to discover. Tiny twinkling lights scattered across a vast, dark canvas, each one a distant sun, perhaps with its own planets, its own mysteries. For as long as we've existed we've wondered, what are those lights? Are they gods, spirits, or other worlds waiting to be found? Our ancestors built myths and legends around them, but they also began to ask questions. How far away are they? What secrets do they hold? Could we ever reach them or even understand them? What else is out there? Are we alone, or is the universe teeming with life and phenomena beyond our wildest dreams? This curiosity is the engine of discovery, driving us to explore not just our world, but the universe itself. It's a force that unites us across cultures and generations, inspiring us to look up and reach out. We build on the knowledge of those before us, always reaching further. Each discovery opens new doors and every answer leads to more questions. The universe doesn't give up its secrets easily. Its mysteries are hidden behind veils of distance, darkness, and time. It challenges us, overturns what we thought we knew, and pushes us to ask new questions. Sometimes it even forces us to rethink the very nature of reality itself. Among the cosmos's wonders, some objects are so strange they seem like science fiction, where the laws of physics break down, and our understanding is stretched to its limits. I'm talking about black holes. These cosmic enigmas are the ultimate test of our curiosity and imagination. These enigmatic objects are among the greatest mysteries in the universe. They warp space and time, swallowing everything that comes too close, even light itself. We can't see them directly, but we know they're there by their profound effects on space and time. Their invisible presence shapes galaxies and bends the very fabric of the cosmos. Studying black holes isn't just about data. It's about confronting the limits of our perception and daring to imagine a reality stranger than fiction. They force us to question what we know, and to accept that some answers may always be just out of reach. So come with me. Let's embark on a journey to the edge of reality, where gravity reigns supreme and the secrets of the cosmos await. Together, we'll explore the unknown and seek to understand the unimaginable. Our quest begins with the most extreme objects in the universe, gateways to new physics and new possibilities. Black holes, the ultimate frontier of our knowledge, and perhaps the key to unlocking the deepest mysteries of existence. So what exactly is a black hole? It's not a hole or an empty void. A black hole is matter packed into an impossibly small space, with gravity so strong that nothing, not even light, can escape. The boundary is called the event horizon, the point of no return. Cross it and escape is impossible. At the center lies the singularity, a point of infinite density where physics as we know it breaks down. Black holes aren't cosmic vacuum cleaners, their gravity follows the same rules as any massive object. If our sun were replaced by a black hole of equal mass, Earth would keep orbiting as usual. You have to get very close to be caught. Black holes are not random destroyers, they're fundamental to the cosmic ecosystem. They shape the universe in profound ways, and they challenge everything we think we know about space and time. If black holes trap all light, how do we find them? These mysterious objects are, by their very nature, invisible to our eyes and even to the most powerful optical telescopes. Yet, astronomers have developed ingenious ways to uncover their secrets, using the universe itself as a laboratory. We look for their influence on nearby stars and matter. When we see stars moving in strange rapid orbits, or notice that something massive is tugging on them, we suspect a hidden force at work. When a star orbits an invisible massive companion, we suspect a black hole. The star's motion betrays the presence of something we cannot see, something with immense gravity. Gas and dust spiraling into a black hole form a superheated accretion disk, glowing in X-rays, revealing the black hole's presence. These X-ray signals are some of the brightest in the universe, and they allow us to pinpoint where black holes are feeding. Sometimes, black holes launch jets of particles at nearly light speed stretching thousands of light years, clear signposts of their existence. These jets can be seen across the cosmos, even from distant galaxies. These jets help us understand how black holes shape their galaxies. They can influence star formation and even regulate the growth of entire galaxies over millions of years. A breakthrough came with the discovery of gravitational waves, ripples in space-time from merging black holes. This opened a brand new window on the universe, letting us study black holes in ways never before possible. In 2015, LIGO detected these waves for the first time, letting us hear the universe's most violent events. The collision of two black holes sent out a signal that traveled over 1 billion years to reach us. Now, we can find black holes that are otherwise invisible. Gravitational waves reveal mergers that would be impossible to detect with light alone, expanding our cosmic census. Each new method brings us closer to understanding these cosmic enigmas. With every discovery, we peel back another layer of the universe's mysteries. Black holes may be invisible, but their fingerprints are everywhere. Their gravity bends light, warps space, and leaves unmistakable marks on everything nearby. We just have to know where to look, and keep searching, as the universe still holds many secrets waiting to be found. Black holes come in a surprising variety of sizes, each with a unique origin story and a distinct impact on the cosmos. These mysterious objects are not all the same. Some are small and fleeting, while others are unimaginably massive and ancient. Stellar mass black holes are the most common type. They form when massive stars run out of fuel and collapse under their own gravity, often after a spectacular supernova explosion. What's left behind is a dense core just a few kilometers wide, but with a mass several times greater than our Sun. Our galaxy, the Milky Way, likely contains millions of these stellar mass black holes, scattered throughout its spiral arms and hidden among the stars. At the other extreme are supermassive black holes, cosmic giants weighing millions to billions of times the Sun's mass. These behemoths lurk at the centers of nearly every large galaxy, including our own, shaping the fate of entire galaxies with their immense gravity. How these giants formed remains one of astronomy's biggest mysteries. Some theories suggest they grew slowly by swallowing stars and gas over billions of years, while others propose they formed rapidly from massive clouds in the early universe. Recently, astronomers have found tantalizing evidence for intermediate mass black holes, the elusive missing link between stellar and supermassive types. These objects may help explain how the largest black holes in the universe came to be. These intermediate mass black holes are hard to find, often hiding in dense star clusters, but they may be the seeds from which supermassive black holes grow. Each type of black hole plays a crucial role in the universe. Stellar mass black holes enrich the cosmos with heavy elements, while supermassive ones regulate galaxy growth and even influence star formation. Studying this incredible diversity is key to understanding the universe's evolution, from the birth of stars to the formation of galaxies. Black holes aren't just oddities, they're cosmic architects, shaping the structure and destiny of the universe on the grandest scales. Their story is deeply intertwined with the story of the universe itself, revealing the hidden forces that have shaped everything we see in the night sky. We're in a golden age of astronomy, with technology transforming our understanding of black holes. Telescopes like James Webb and global radio networks give us unprecedented views of the cosmos. In 2019, the Event Horizon Telescope captured the first image of a black hole's shadow in galaxy M87. In 2022, it imaged Sagittarius A*, our own galaxy's supermassive black hole. These images confirm Einstein's theories and mark a monumental achievement. Behind the scenes, artificial intelligence sifts through mountains of data, spotting patterns and simulating cosmic events. AI accelerates discovery, finding what humans might miss. The detailed image of Sagittarius A* lets us study a supermassive black hole up close. These advances turn abstract theories into observable reality. Technology is opening new windows on the universe, and we're just getting started. Just as we think we understand the universe, new discoveries surprise us. The James Webb Space Telescope has revealed galaxies separated by vast distances spinning in sync, a cosmic dance no one expected. Our models predict galaxy spins should be random, shaped by local conditions. This synchronization challenges our understanding of cosmic structure. Some scientists think dark matter filaments or unknown forces might be at play. Others wonder if it hints at new physics or properties of the early universe. It's a genuine mystery, forcing us to rethink our assumptions. Science thrives on such surprises. One observation can change everything. The universe is more complex and interconnected than we imagined. Each new puzzle pushes us to ask better questions. Despite our progress, black holes confront us with the limits of our knowledge. What happens at the singularity? Our best theories, relativity and quantum mechanics, disagree. We need a new theory, quantum gravity, the holy grail of physics. Another puzzle, the information paradox. Does information vanish in a black hole, or is it preserved somehow? Hawking radiation suggests black holes can evaporate, but the fate of information remains a mystery. We're also puzzled by how supermassive black holes grew so quickly in the early universe. And how do they shape galaxy evolution? the answers are still out there. These mysteries aren't failures, they're the frontiers of science. Every answer leads to deeper questions. Our job is to keep exploring, questioning, and pushing the boundaries. Our journey has taken us from the wonder of the night sky to the reality of black holes. Human curiosity, powered by technology, is revealing the universe's deepest secrets. Discoveries like the image of Sagittarius A asterisk and synchronized galaxies are milestones in our story. They change not just what we know, but how we see ourselves. Learning our place in a vast ancient cosmos is humbling and empowering. We, confined to a tiny planet, can reach out and comprehend cosmic wonders. Science is a journey, not a destination. Today's knowledge is just a progress report. Future generations will build on our discoveries and uncover new mysteries. The quest for understanding never ends, the horizon always recedes. So next time you look up, remember, you're part of this grand exploration. The cosmos invites us to learn its secrets, and our curiosity is our spaceship. The greatest discoveries are still ahead, waiting in the darkness between the stars.